or the length of the leg of a triangle. And those are the front and the back. The second page is going to be your homework. And these will be due Wednesday. Or if you're second period and you're watching this right now on Wednesday, it will be due Thursday. You will also be required to do have these two IXLs. You should already be working on R1. You will have R2 that will need to be finished up as well at an 85% so that I can record those on there as well. So those will be your two IXLs that you need to work on as far as your IXLs go. Your homework is a front and back that you'll need to work on. Okay? So use these notes to help you work, and the notes from Monday to help you do the Pythagorean theorem homework and R1 and R2 on your IXLs. So let's just go ahead and get straight down to it. So what happens is the Pythagorean theorem, kind of what we talked about, it only works for right triangles. You can see right there. So a right triangle here is a triangle that's got a little box in the middle on the 90-degree angle that tells me it's a right triangle. Little things you need to know about these things that you have, and we're going to label these things A and these things B. When I label those A and B, those things are known as the legs of your triangle. You have one leg and you have another leg here. I should actually label that one A and then label this one B. Okay, so you have leg A and leg B. So the things that are on the outside or adjacent to the right triangle are called their legs, and we label them A and B. Now to find the hypotenuse, it's straight across from the right angle. So you see the right angle, it's straight across. We call that C, and this is called your hypotenuse. So this thing right here is called the hypotenuse. And we call that C, or side C, and it is always the longest side of your triangle. It's not the shortest side, it's always the longest side. So this value, C, should always be bigger than B or A in this case. Okay? To do the Pythagorean, so to be able to find out what these sides are, we use what is called the Pythagorean theorem. It was founded by a Greek mathematician called Pythagoras, and they called it after him the Pythagorean theorem. It tells us how long, or tells us how the side lengths of the triangles are related. And then what it says is, if any right triangle, the square of the hypotenuse, which is C, side C, so if I square C, is equal to the sum, that means adding the sum of the square of the other two sides. So A squared plus B squared in this case. So if I take the square of A and the square of B and add them together, it's going to give me the square of C. And this is what the Pythagorean theorem states right there. And we did some examples of those yesterday in our notes that will show you how we did those, and you should have been practicing on that IXL R1 about finding the hypotenuse. So the first four questions here are just asking you to label each side of the triangle below, A, B, and C. So the first thing I like to do is label the C. The C is right across the right angle. So I'm going to draw these arrows, and you can see that right across the right angle is going to be the C, the hypotenuse. That's the longest side of your triangle. The other ones are just simply the legs, or A and B. So I have a leg here and I have a leg here. So I'm going to call that one leg A, that one leg B. Here's leg A, there's leg B, and so forth. You should be able to get the rest of those if you see those, A and B. There they are. And it really doesn't matter which one you call A or B, but I always like to call the bottom one A just to kind of keep it the same throughout when I work these problems here. So there we have it. But remember, the hypotenuse is always right across from the right angle. That's your longest side, C. All right? So now what we're going to do here down at the bottom of number 1, 2, and 3 are three examples to be able to find the missing side length of our triangle. Such in this case, we're going to be missing the hypotenuse. So we're going to find the hypotenuse in all of these. So we have a missing C. This is your right angle, because you see where the L shape is. Straight across from it is the C that we're missing. The same thing here. Right there is the missing side. I'm looking straight across with the hypotenuse C. And there is my right angle right there that makes the L shape. And I'm going across, I'm missing the hypotenuse here. So I'm just going to use the equation a squared plus b squared equals c squared. It's right up here on the top that I'm going to use. And when I want to write it down each time and fill in what I do know and what I can solve. So here we go. So I have here, so I'm going to write down the equation a squared b squared equals c squared. I know I'm missing the c. I'm going to call this one my a and call this one my b. And I'm just going to fill in what I know. So my a goes right here, which becomes 3 squared. My b is now 4, so it becomes my b squared. So it becomes 4 squared now. B equals c squared. So I can use my calculator here and go 3 squared is 9, 4 squared is 16, and when I add 9 and 16 together, I end up getting 25 equals c squared. Now remember, that is the area of the square that juts outside here. So like if I were to draw a square here, this area that I'm marking in blue is 25. But I don't want that 25. I want to know the length of the side, or in this case, that part right there. I want to know that length. I'm going to make it darker here for you so you can see it. I want that length right there. So what I need to do is I need to find out, okay, well, what is this number that can multiply it by itself that will give you 25? So I do that by taking the square root of 25. That equals 5. So that is 5. So my C here is 5. So C is going to equal 5. And that is my answer. That's my hypotenuse of 5. Okay? If I do the next one here, same type of example. I have my rectangle here, so that's my right angle. Straight across is my C, my hypotenuse. And so I know that I can call this A, and I'm going to call this B. I'm looking for my hypotenuse. I'm going to fill in everything I know using my Pythagorean theorem. And so what do I have here? I've got my A, which is going to be A squared goes there. So it's becomes 7 to the second power. And then my B, which becomes 24 to the second power, equals C squared. And when I do that on my calculator here, I'll pull it out here so you can see it. It's going to be 7 to the second power plus 24 to the second power. I add that up, and it gives me 625. So I know that my C squared is 625. But then again, remind yourself that that is the area of the square up here. That area of the square is 625. Now I don't want that as my answer because I'm just looking for the length. So there's a length there that I need. And to be able to do that, I take the square root of that number. So I'm going to take the square root of 625 of the area, and it's going to equal 25. So my C here is 25, or the hypotenuse is 25. Now I have that one completed. I do number 3 the same way as I did the rest of those. I've already labeled my hypotenuse. That's the missing side because it's across from the right angle. I'm going to call that A, call that B. I'm going to fill in my equation. A squared plus B squared equals C squared. And when I take these, I have my A here, and I'm going to fill it in from my other A here, substitute him in. So he becomes 7 squared. My next number here is B. I'm going to fill him in. He goes right there. He becomes 12 squared to the second power. And that's all going to equal my hypotenuse squared. Put that into my calculator, 7 squared plus 12 squared, so it's going to become 7 squared plus 12 squared. That is the relationship amongst them. Square the two sides and add them together. It tells me 193. So I got 193 is C squared. But remember, that is not the answer I want. I want the answer of what would be the side length, not the area. That is telling me the area of C. And I don't want the area of C. That's 193. I want to know the side length. So I got to take the square root of that. Just take the square root of 193. Put that in here. Second, x squared, 193. And it tells me 13.89. And I'm going to round that up. 13.89 is going to be 13.9. So I get 13.9 for my answer there. So my C value there is 13.9. That is my answer. So C is equal to 13.9. So I have all three sides now of my triangle. So this right here is finding the hypotenuse. So this is finding the hypotenuse. E-N-U-S-E. And this is also like the IXL R1. This is what R1 is about. So if you can do those, R1 will help you. This will help you with doing R1. These three right here. It's the exact same steps that it's going to do with your IXL R1. Those three problems right there. Okay? Finding the hypotenuse. So let's take a look at the next one. So what happens if they don't give you the hypotenuse? They give you the hypotenuse, but you're missing a leg. So this right here is the missing a leg. This is what R2 is about. IXL R2. So what do you do if you're missing a leg and they give you a hypotenuse? Well, let's see what would happen. So if you, it's pretty much the same thing, just a little twist to it. So what happens here, we're going to put our little box in here to the right angles. There's our right angles right there. Those are my L's. I'm going to label the sides. So this will be my C because it's my hypotenuse. This is my A. I'm missing B. Okay? So think about it. If I take these two sides and add them together, I should get this answer of 13 after I take the square root. So let's just use the Pythagorean theorem and write it down. Use the information that I know, and let's fill it in. So I know the A. And A is 5, so that becomes 5 squared. B, I do not know what B is, so I'm just going to write him down, B squared. That's what I'm looking for. C, I do know, 13. So I'm going to put him here, 13 squared. This becomes a one-step problem. I need to solve this problem for B. And what happens is I have this right here, 5 squared, that I need to move over to the other side. So instead of adding to get the answer, I'm going to subtract. So I'm going to subtract 5 squared on both sides of the equation. And when I do so, I end up finding that B squared is going to equal 13 squared minus 5 squared. So it looks like I'm actually subtracting these two from each other instead of adding like I did on the other side right here. When I knew the A and B, I added. But when I'm missing a side, I'm going to subtract. So when I subtract this 13 squared from 5 squared, I get 144. So I know that the B squared is 144. Remember again, that 144 is just the area of that B square. And I don't want the area, I want the length. So I don't want the area, I want the length. So I need to take the square root of that. And when I take the square root of 144, second x squared, I put it in 144, it tells me 12. So I know that B is equal to 12. So that is the missing length right there. It's 12. So just to kind of recap, when I know the hypotenuse and a side, and I'm missing the other side, all I need to do is subtract. And there's the math right there for you. Let's try another one. I'm going to fill these in. Here's my C. I'm going to call that A. I'm missing B. You can do the other way around. It doesn't matter whichever way you want to call it. This could be A, that could be B. So I'm going to put these things down here. I'm going to fill in. I got A squared plus B squared equals C squared. Okay, I'm going to fill these in what I know. I know the A is going to be 6. It goes in for the A. I know the B is going to be 10. It goes in right there. I'm sorry, not the B. It's going to be the C, I'm sorry. It goes right there. So that's B squared. And that goes here. 10 squared. So I just do the same thing. I need to get the 6 over here, so I'm going to subtract on both sides. And so what do I end up with? I end up with B squared is equal to 10 squared minus 6 squared. There it is again. I'm subtracting. I just took these two and subtracted it, put it in my calculator, and let's see what happens. So I get 10 to the second power minus 6 to the second power gives me 64. So I know that B squared is equal to 64. And I take the square root of 64. Well, that would be second x squared. Type it in, 64. I get 8. So I know that my missing side is 8. And now I'm finished with it. Okay. Number 6 is the same thing again. Same process that you're going to be here. Just fill in what you know. I know that there's my missing side. I have this side, which is my C, my hypotenuse. I'm going to call this my B, call this my A. I'm going to fill in what I know. I'm missing side A. I'm missing a leg. So I'm going to fill it in. A squared plus B squared equals C squared. I don't know the A. I know the B is 16. He goes there. And I know the C, which is 24. So I just do the same thing. I need to get everything away from the A squared, so I'm subtracting over. So I get A squared is equal to 24 squared minus 16 squared. Once again, subtracting these two, the biggest and all that. Put that in my calculator here. 24 squared minus 16 squared gives me 320. Take the square root of 320. Gives me 17.88. I'll check it around to 17.9. So I know A squared is, when I get that, is 320. So my answer here, after I take the square root of 320, is 17.9. And that is my missing side right there. So basically, in a nutshell, when you have a missing side, all you're doing here is subtracting the hypotenuse from a side. I just subtracted C from A, C from A, or C from B, and took the square root. It's pretty much straightforward of what I've done on this case. So if you have a missing leg, fill in what you know, and you're just going to end up subtracting.